All right, so a quick video here of problem number 30, which asks, which is it, the moon or the sun, which exerts a greater gravitational force on Earth? Well, what we got to do is figure out the gravitational force. Now, you could run the numbers and crunch up the numbers and determine the gravitational force exerted by a person standing on Earth. I'm sorry, I misstated earlier. It's a person standing on Earth's surface. So you could crunch the numbers and figure out the gravitational force exerted by the sun on a person standing on Earth's surface, a person of some unknown or indeterminate mass, and the same force exerted by the moon. And you'd have to get them in terms of the m and the mass of the individual. But this is something we've been doing all year. And when we try to compare two things or see which one is larger than another, we can express them as a ratio. So if we find the ratio of the force of gravity exerted on a person at Earth by the sun and to that of the force exerted by a person by the moon, on a person by the moon, then we can determine which is greater. All right? If this ratio right here turns out to be greater than 1, then the force exerted by the sun is greater. If it turns out to be less than 1, then the force exerted by the moon would be greater. Pretty simple and straightforward. In other words, a way of saying it is that the force exerted by the sun is going to be this ratio times greater than that exerted by the moon. Okay? So all we got to do is put in our expression for the force exerted on the individual by the sun. Okay, so here it is. The force exerted by the sun is g, the gravitational constant, times the mass of the sun times the mass of the individual. Now remember, we were never given a mass of the individual, divided by the distance to the sun squared. All right, and we're going to divide that by g, the gravitational constant, the mass of the moon, times the mass of the unknown individual, divided by the distance to the moon squared. So what you can see is particularly handy about this situation is the g's cancel out. The unknown mass cancels out, and all we end up with is the ratio of mass of the sun over the distance to the sun squared, divided by mass of the moon, divided by the distance to the moon squared. All right, so we have a complex fraction here. If we just rearrange it, we end up with mass of the sun times the distance to the moon squared, divided by mass of the moon times the distance to the sun squared. And when we crunch all those numbers out, we get a number that is roughly 178. And that is, I said it before, if we look at this ratio, we can say the force exerted by the sun is 178 times that exerted by the moon. You can see if we just rearrange this algebraically, and we all we got to do is multiply each side by the force of gravity exerted by the moon. So just take all this and copy it. Wake up. All right, bring it down here, and then we can go like this and say, just algebraically, multiply each side by the force of gravity exerted by the moon. Come on over. Moving slow. There we go. All right. So now we get force of gravity of the sun is equal to 178 times that exerted by the moon. And one of the things I said in class was, if you think about it, doesn't that make sense? Which one do we orbit? The one exerting the greater gravitational influence. There are more things than that to consider, but it does make sense if you think about it from a sort of conceptual standpoint. That is number 30.